Hello, today we're going to talk about section 4.2, which it goes over logarithmic functions. On 4.1, we looked at exponential functions, and I had mentioned that exponential functions and logarithmic functions are um, inverses of one another. And so today we're going to see some of the properties that exist because they are inverses of each other. We are going to start off with how to convert between logarithmic and exponential functions. This is probably one of the most helpful things to do. A logarithmic function, y equals log b of x, or log base b of x, is called a logarithmic function with base b, where y equals log base b of x is equivalent to b to the y equals x. So that means that anything that we see written like this, we can rewrite like this, okay? So let's test it out. Write each equation in exponential form. So log base 4, 16 is equal to 2, so that means 4 to the second equals 16, which we know is true, okay? Log base 5 of 0.2 equals negative 1. Well, that's going to be 5 to the negative 1 equals 0.2. If you think about it, 5 to the negative 1 is just 1 over 5. 1/5 is equal to 0.2. Cool news. I can put that exponent 1 there. We wouldn't typically write that, but if you want to see, remember that that negative exponent kicks that base into the denominator. Okay, here we have log base 8 of 1 equals 0, so that means 8 to the 0 equals 1, which we know any number to the 0 power is going to be equal to 1. Same thing here, we're going to take the base 23, put it to that exponent, and that's going to be equal to this value of 1. Okay, so then if we know how to take a log function and rewrite it as an exponential function, then we can take exponential functions and rewrite them as log functions, which will also be a very helpful tool to have. So this one, the base here is 2, so I'm going to label that B. Okay, then we have the value that it's going to be equal to and the exponent. Okay, so if I'm going to rewrite this, this is going to be log base 2, because that's our base. The value that it's equivalent to is 16, so that goes there. And then it's equal to whatever our exponent is. Okay, same thing here. This would be log base 27. Okay, and the value that it's equal to goes here, and the exponent is what it's equal to. Okay, this one looks a little tricky, but my base is 1/4, so that's going to be log base 1/4. 16 equals negative 2. Remember, that's just saying that 1/4 to the negative second power would equal 16. Okay, so this is how we convert between log functions and exponential functions, and between exponential functions into log functions. Okay, so when we are then asked to evaluate logarithmic expressions, what we're doing is we're thinking, okay, well, log base 12 144 equals what? Well, that's saying 12 to the what power equals 144, so that x has to equal 2, because 12 to the second power, or 12 squared, equals 144. So again, this is why rewriting these as an exponential function might help. So if we take log base 4 of 64 equals what? Well, that's 4 to what power equals 64? 4 to the third power equals 64, so x is going to be equal to 3. So the last one, we have log base 5 of 1/125 is equal to x. So it's saying 5 to what power equals 1 over 125? Well, that means I'm going to have a negative exponent because it's going to kick that base down into the denominator. And so I have to think of, well, 5 to the what power equals 125? Well, 5 times 5 is 25. 25 times 5 is 125. So it's going to be to the third power. to get a 125, but it needs to be negative since it's in the denominator. So in this case, my value is going to be negative 3. Okay? The big note right here, and I'm going to point this out because it actually shows up quite a few times, at least twice in your homework, is that when I have radicals, remember that a radicand is the equivalent to having a fractional exponent. So if this is the square root of x, that's the same thing as x to the 1/2. If I have the cube root of x, that's equal to x to the 1/3 power. So when I think about these, if I have log of 64, base 64 of 8 equals what? Well, you're saying 64 to what power equals 8? Well, in order to get 8 from 64 with a power, I'm going to end up taking the square root. The square root of 64 is equal to 8. So that means that in this case, my x value must equal 1/2. Okay, so we will end up, look at that nice little cat hair right here. Anyway, sorry. So if you have a situation where a square root or a cubic root is being taken, then make sure that you use the fractional exponent. So the last bit on this first video is going to be about common logarithmic functions. So the ones that we've seen earlier all had a prescribed base. So log base 2 4 equals 2. Okay, so the base was written out right here, but we actually have some common logarithmic functions or logarithmic bases, and when we have a common logarithmic base, we don't actually write out the base, it's just assumed. So the first base that's very, very common, and it should make sense with our number system because we're in a base 10 number system, is log base 10. So anytime you have y equals log base 10 of x, we actually just write it as y equals log of x. So anytime you have no base written with log, the base is equal to 10. Okay? The natural logarithmic function ties back to that number e we discussed before. So anytime we have log base e, we actually call that the natural log. And the natural log, we would write y equals ln of x, which stands for the natural log of x, which it has a base of e. Okay, and remember last time in the 4.1 section with exponential functions, we talked about how e is a number. Okay, it's a very common number. It shows up a lot, lots of applications. Remember, Pearson has that really cool math talk. So if you want to go in and look at that math talk, that'd be awesome. So the next thing that we're going to do, though, is going to evaluate some of these common logs. So the first one that we have there is log of 100. There is not a base written, okay? So that we assume that the base is 10. So we're saying 10 to the x equals 100, so x equals 2. So evaluated log of 100 equals 2. For the next example, we have log of 1 10,000th, okay? So, or we're going to look at this, and we know that this is the same thing as saying 1 over 10,000, which would be 1 over 10 to the 4th. So if I were to evaluate this, evaluate this, this would be equal to -4 as my exponent, okay? So the next one, we have the natural log of e to the -3. This is actually going to come from a property we're going to see later, but the result to this, since the base is e, this is just going to be -3. And this one right here, natural log of e to the 10, e to the 10th is going to be equal to e to the 10th, so that exponent is 10. Because think about this, the base is e, and then to the x, what we're trying to find, equals e to the 10th. So that means that my x has to be equal to that 10. So evaluated, we get 10. Okay. The next part, you're going to use the calculator buttons. You're going to either use the log button, which automatically uses base 10, or you're going to use the natural log button, which automatically uses base e. So you're just going to type in log of 200. When you do that in your calculator, I'm going to wait like 3 seconds to let you type it out or type it in, compute it. Okay, you end up getting 2.3010 rounded to the 4th decimal place. And if you do 10 to the 2.3010, that's going to give you back where you started from, 200. So I'm not going to write the check for each of these. You guys can do that on your own, but I'm going to write the values for each of these. So this one here would be negative 1.1308. This one right here, the natural log of 200 is going to be 5.2983. And the natural log of 1.005, or 1 and 5 thousandths, is going to be 0.0050 when you round. Okay, you can check me on all of those, verify that in your calculator. Make sure you're using the correct log, whether it's the common log of base 10 or the natural log with base e. In part 2 of logs, we're going to look at the basic properties of logs and apply them. We're going to graph some logs, including transformations. And then lastly, we're going to look at an application. Okay, so please make sure you watch the next video, 4.2 logarithmic functions, part 2.